Hi guys, we're going to focus a little bit today on equations of circles, midpoint and distance and slope. Some of this is review and then there's a good chunk of it that's going to be kind of new and difficult, especially the equations of circles. Now if you took geometry last year at a high school, you probably didn't get to equations of circles, so that might be new to you. And if you took it at a middle school, you most likely did get it. But with COVID, who knows what we all got. So it's just good to go over it again. So this is going to be what we're focusing on. Now you're going to notice that this says a lot of things. You're going to see pages like this at the beginning of every lesson. Up at the top, it'll tell you what lesson number we're doing as well as the title. And over here it says the page in the book that we're going to start on and our objectives. So you're going to see this every time we do it. So we're going to start with domain and range, what those are, and what discrete and continuous graphs are, because not everybody really knows that or was ever really taught. For a reminder for some of you, this is where the quadrants are and what they're labeled as. They go counterclockwise. So we're going to start by just quickly talking about domain and range. Domain is usually all numbers that are on the x side of things, and range happens to be our y's. So domains are x's, ranges are y. Now it's really tricky to describe with this particular graph what the domain is. The first answer that might come to your mind, like a lot of people will say, oh, the domain for this is between the lowest point, which is -4, and the highest point, which is +4. And those are noticed both x's. But that's actually not accurate. This is what we would call a discrete graph. It's not continuous. And so our domain for this graph would need to be specific values. Notice that there's not a line connecting these dots. So it's just the x coordinates that are part of your domain. So we would do this weird little squiggly bracket thing, and we would try and do our best to list them from lowest to highest, but that's not the most important thing, and that's my domain. If you're someone that was like insistent, oh, it's -4 to 4, that's not accurate. These are specific points. Discrete means that you have only specific distinct points. Now our range is the same, it's just that it's the y values this time. So again, some of you might go, well, it's -5 to 3. No, but it's not, because it's specific points. So again, we're going to do our squiggly bracket, and we're just going to go ahead and list all of our specific y values. And there we go. That's domain and range. Now, what's the main difference between discrete and continuous? Continuous, you would want to write something like the range as -5 is less than or equal to y, which is less than or equal to like +3. That would be what we'd consider a continuous range. It would be as if I had connected these dots. And it's not just the values of -5 and -3 and -1. It's all the infinite points in the middle of them. So that would be continuous. Now here's the big distinctive issue. People think that they understand continuous. And people think that continuous has to continue in both directions, like if I was to put arrows on this. And while that does continue, continuous in particular for us means that it is between any particular two sets of points, there's infinite values in the middle of them. So continuous, you could have just between this point and this point, and that's continuous. Just because it ends does not mean it's discrete. Discrete means specific points. Now, continuous could have arrows, or it could be a segment where it ends. But continuous means there's a continuous infinite amount of points between whatever you have selected. So that's our main difference and the beginning starting of all of this. So let's talk about equations of circles. Here's your equation of your circle. You're going to want to start a notebook of some sort and start writing things down like this. Even though we are online, it's still really important you're taking notes. If at some point we come back into the classroom or you take your IB exam, this is where it's going to come in really handy. Your x and y are variables, that means letters. You don't really change those. They are x and y. Your h and k is your center coordinate point, and your r is your radius. Notice that you're squaring them. This is really similar to the distance formula. It's all related. So we're going to plug in values for the h, the k, and the r, but we leave x and y alone. For it to be an equation, it needs to have the two variables and an equal sign, so we're going to leave that alone. So if, for instance, we had a center value here, of h comma k, meaning let's say that this was at comma 3 comma 4. There we go. And my radius, we'll just say your radius is 2. Well, we could just fill those points in really fairly easily. 3 would go in here, 4 would go in there, and my radius is 2. So my overall equation, if that was what I'd picked, is x minus 3 squared plus y minus 4 squared equals 2 squared. There's no need to try and reduce this. Do not try and FOIL the hell out of that because really it's not needed, and this is the format of the equation, so this is what you leave it as. The only thing you could potentially reduce would be the 2 squared. Now you might want to leave it sometimes, other times it's easy enough to change it to 4. So there we go, that's the basics of your equation of your circle. Now we're going to start with some real easy stuff, and this might seem a little bit harder, but we're in pre-calc now. This is a senior level course, and it's really kind of the basics of some college level math, so we step it up a little bit. IB math is really more about the why than the how, and so we start making you think. This says, how can we find the center of the circle if we know that the 2 coordinates are located on the circle? Now at any point of these videos, please feel free to pause the video, try the problem on your own or think about it, and then go ahead and play it to see how it went through. That's a great strategy for how to watch these math videos. So we know our 2 coordinates, and the whole goal is to find the center coordinate of the circle. That's what they're asking. Now a lot of you just want to count and you want to look at it and go, okay, 1, 2, 3, 4, 5. It looks 5.5 and -1. Done. Well, in IB, they almost never make it that easy on you. So you have to be a little bit more careful than that and make sure you're getting it exact. So looking at starting this, you might want to just stop and think about what would be your best method to start this kind of a problem. Now, if I'm looking at it, what screams at me here is midpoint. Now, if you don't remember midpoint is the average of your x's and the average of your y's. This is the formal formula. Now, I don't remember that. No one's going to remember that, and I highly recommend you don't try memorizing formulas this year. It's a waste of time. When it comes down to it, you're never going to remember that stuff for your test. What you need to know is what it means and how to use it. So the what does it mean is really what's important. Midpoint is an average. It means what's the middle. Now, before you even use this, look at it. If we use our x coordinates, what's the middle of 5 and 6? Well, it's obviously 5.5. That would be a good guess. What's the middle of 6 and -8? Now that one's a little bit harder, but if you were to use like a little number line and kind of see where they meet in the middle, it's probably somewhere around -2, -1, 0, somewhere in there. So we kind of can see it looks like -1, so that's my guess. So just by reasoning through with what's a middle, that's my guess for that coordinate point. So I'm going to go ahead and use my official formula. It doesn't matter which order you add them. So 5 and 6, divide it in half. We've got our y's, which is 6 and -8, and dividing it in 2. So we're looking at this, we got 11 divided by 2, so 5.5. And then we have 6 and -8, which makes -2. And when you divide it in half, you get -1. Wow, look, we're right. So easy. Not terrible. I love that. Now they switch and they say, how can you find the length of the radius? Now that one's a little bit harder because you got to remember your distance formula. It's been a while. So our distance formula doesn't, again, really matter what order you pick, but whatever you pick you want to keep with. So your distance formula is our y2 minus y1 squared plus our x2 minus x1 squared. And what is this big giant thing out here? That's called a square root. Now, you need to be really careful on this. When we have the square root of all this crap on the inside, it doesn't mean take the square root of this and then add it to the square root of that. That's a very different equation. So you want to be really careful with how you go about doing this. So the square root is always done last. And if you want to put an extra set of brackets, so like according to order of operations, you do all the crap on the inside first, then take the square root, then you need to remember that. So finding the length, and it says, and you want to be careful here, find the length of the radius. So there's 2 main ways on this problem. We already know this coordinate point, so we can use, oops, I didn't mean to put that, little tiny comma. we can use that coordinate point and one of the other two and find the length of it. The other main way is find the length of the whole length. Do anyone remember the name of that? Radius. We call this diameter. So you can use the length of the diameter and then cut it in half. So it makes no difference which one you pick. Pick one. I'm probably going to pick the easier set, I guess. I'm just going to pick these two and deal with that, but just pick some. So the hardest part of this is making sure you put them in the right spot. My y2 minus y1, we've got our -8 minus -1, and it's squared. Then we have our x2 and our x1, so 6 minus the 5.5. And it's again squared. So that's a good way to go through and do this. You got to just make sure you're following your orders of operations, pluses. So on this side, I have -8 plus 1, which is -7, and I'm going to square it, which makes it 49. Over here, I've got 6 minus the 5.5, which is, of course, just the 0.5, and you got to square it. And our 0.5 squared, I think, is just 0.25, isn't it? That sounds kind of weird, but there you go. And we still need to take the square root. So we do need to add these first. Don't square root that and square root that and then add them. Remember, that is the last step. So it's the square root of 49.25. And some of you don't like that, but that's your answer, and it's exact. This year we're going to work a lot on exact answers. So there we go. Not too bad. That's the distance. Now we're going to move into finding the equation of it. We already know our center point. We've calculated it, 5.5 and -1. We can pick any other point. It doesn't make any difference what you pick. So we need to make sure that we're using our center point and then one of the others to fill in what we want for our equation. We also need to make sure that radius has been calculated, and we already found our radius. So here's our equation. Hopefully you can see it on the bottom of the screen here. Why don't we just pick the center, the 5.5 and the -1. We already calculated the length of the radius. It wasn't pretty, but it was root 49.25, if I remember right. Yuck. But there you go. That's pretty enough. So that's not that bad. It's not pretty, but it fits. So remember, we're going to plug these in the H and the K and the R spots. So it's ugly looking, but you need the X minus the H, which in this case is the 5.5 squared. That's the H. This is your K. Plus, we have our Y minus the -1, so hopefully you're noticing that needs to be added, squared. And then we have to put in our radius squared, so root 49.25 squared. Now, like we said in the past, don't mess with these. Don't try and FOIL those. Leave those alone. So what we do need to do is go through and just kind of finish up that radius. So the 49.25 squaring it, that's going to cancel out the square root. So my final answer is x minus 5.5 squared plus y plus 1 squared equals 49.25. And that's it. It's not pretty, but it works. All right, moving right along. Now we're going to practice graphing. And while this is not geometry, you're more than welcome to get a compass. But not all of us have compasses at home, so I'll show you the best way we can do it by hand with no compass. So to start with, you need to figure out what your radius is as well as your center point. Your center point, this is the H and the K. Remember, the formula has X minus the H and Y minus the K. And why is that important? Well, it's important because your H is not -2. Your K is not +3. It's the opposite of those. So my center point, and I'm just going to write it, is +2 and -3. Because if I was to plug -3 in here, that would change to plus. Now the radius is the hard part. We want to just kind of go, oh, it's 12. But it isn't 12. It's, radius squared is 12. So what's just R? How do you set that up? How do you solve it? You're really saying r squared is 12. Well, how do you get rid of a squared? You square root. So my radius is technically root 12, and we go, well, what the heck is that? I don't know what that is. I'm typing it in on my calculator. It's approximately 3.5. Okay, if we're going to graph this by hand, 3.5 is a pretty good amount. So I'm going to go find 2 and -3. So I go over to 2 and down to -3, and I put a nice looking dot. And if you have a compass, you can set the stabby pointy end here and then, move it open and then draw your circle. But since we don't have a compass, we're going to just do the best we can with what we got. And I'm going to count up 3.5, down 3.5, and side to side 3.5 on each side. Now I'm going to do my best to eyeball a hopefully fairly perfect looking circle. There we go. Hey, I'm the best. Looks awesome. Love it. And that's how you're going to do it at home. Just do the best you can with that. And here's the real new part of the lesson today. And this is the part where it's going to be hard. You're going to practice this and you're going to work on it. It says write an equation in standard form and then graph it. Well, the graphing we don't care about. That's easy enough. The hard part is how on earth do you take that and put it into an equation of a circle? Now, just so we're all on the same page, standard form, they mean of a circle, is x minus h squared plus y minus k squared equals r squared. Like, look at this. It's not in the same format at all. Oh my gosh. So here's the part of the lesson you're going to probably want to pause, rewind, relook at over and over again. There's steps to this, and there's a format for it every single time. We're also going to be doing something called completing the square. Now, you may have done this in Algebra 1, probably not. You hopefully did it last year in Algebra 2, but you probably weren't very good at it. It's not super easy. Completing the square means we're going to take something that's ugly like this and kind of create little quadratic equations from it. And it's not easy. So there's a format to it. We're going to work through it together. The first step is to group. And so I'm going to write group. And we want to group our x's together and group the y's. And then we want to group the whole numbers. So I'm going to rewrite the problem with my x's put together. And I'm going to put a little space after the x's because we're going to complete that square. I'm going to then put my y's, y squared and 10y, plus another little space. And I have an 18, so I'll just write that out there, equals 0. When we complete the square, it's not really very helpful to have whole numbers in it. You want to just keep the letters. So I'm going to go ahead and move that 18 to the other side and instead say equals -18. Remember, I'm moving. I can't just pull 18 over. I got to subtract it to the other side. So that's where that's going. When we complete the square, we take the b, divide it in half, and square it. That's completing the square. So the b value is here, a, b, and c. So the b is the one that has the single variable, no squareds. So 4, I'm going to divide it in half, that's 2, and square it again, I get 4. I'm going to plug a 4 in here. Now here's the trick with completing the square. If I put it here, I have to balance my equation. There's an equals sign. I can't just randomly add a 4 to this. So if I add a 4 here, I gotta add a 4 on the other side. So since I put 2 little blanks in, I kind of like to put 2 little blanks in over here. It reminds me that I gotta fill them both in. Same thing over here. Half of 10 is 5. Square it, you got 25. Once we are done with our grouping, we're going to go ahead and put them into factor groups. Okay? So that means this whole section, I'm going to put it into something that has like an x plus whatever. And what is it when you were to take a quadratic like this and factor it? It's the x plus 2 and x plus 2. So we'd say that's x plus 2 squared. If I was to take this and FOIL it, it would become that. Same thing over here with the y's. I'm going to do this one separately. I'm going to find out, y plus what would make this equation? It's actually y plus 5. Now some of you are like, whoa, how on earth did you do that? Whoa. Well, it's really fairly simple. You can either take the square root of the c values, or you can divide the middle b's in half, and that's going to be what your factor pair is. And then finally, the -18 plus 4 and 25 is a total of 11. So this looks pretty similar. So my center point is -2, -5. My radius, r squared. I've got 11. Remember, 11 is an r. 11 is r squared. So you got to square root each side. And even though that's not pretty, it's the root of 11. And if you go, whoa, what is the root of 11 in terms of actual decimals? Well, root 9 is 3 and root 16 is 4, so it's somewhere in the middle. So we'll say 3 point, I know it's about 3.3. So to graph it, you're going to do exactly what we did before. Go to -2, go to -5, count up 3.5, 3.5, 3.5, and go ahead and make your circle. Beautiful. Now that's a hard problem. Okay, here's our last little bit of reminders, and this is about slope. So slope, you can see the formula up here. It's a good thing to go ahead and copy down. You got your y's on top of your x's, and hopefully you remember this. We're not going to spend time calculating slope. You need to know how to do that at this point. What we do need to talk about real quick is parallel and perpendicular lines. And what do you know about their slopes? So hopefully your teacher has talked about something called opposite reciprocals or negative reciprocals. But those are kind of the key words you need here. So parallel lines are when on your grid you have two that are completely even. They never cross. Okay. What do you notice about the slopes of these? Well, the slopes on parallel lines are the same. If you have perpendicular, your slopes are what we call opposite reciprocals. For instance, if the slope of this one's 3, you're going to flip it over and make it negative, and that one would be -1/3. So that's how we deal with parallel perpendicular. Those are the key concepts you need. So if I have 3 for my slope, what's its parallel slope? 3. What's the parallel slope to -2.5? -2.5. What's the parallel slope to -1/4? -1/4. Those are the easiest ones ever. For perpendicular, they're a little harder because the top two are not in fraction form. So you might want to just put them in fractions. -2.5, ooh, you might need to think on that one. Let me show you a quick little tip on your calculator. If I type in -2.5, this math button over here, I can click it. And the very first option is frac. That means turn it into a fraction. And woo, look at that. Isn't that pretty? It does it for me. So I got -5/2. So to make these parallel, or not parallel, I'm sorry, perpendicular, I'm going to flip them over, make it opposite, negative. So this one I'm going to make 2/5, and it's already negative. I leave it as positive. My last one is going to become 4/1, which is just 4. Since it's negative, it becomes positive. So that's your basics on slope. Now you're going to start seeing quite a bit of word problems, and this kind of stuff, it's not really about just calculating slope. It's really about understanding what is slope. What does this mean? So let's read it real quick. It says, while there are many exceptions, numerous studies have shown a close relationship between an average height and average weight. And by the way, when you were babies, your parents constantly took you to the doctor. I know because I have 2 babies and it's a pain in the butt. But you have to take them to the doctor all the time, and they weigh you and they measure how tall you are. They actually also take the circumference of your head. And all of these things are supposed to be in proportion to other children. So this says, suppose a person is 70 inches tall and weighs 165 pounds. Another person is 64 inches tall and weighs 142 pounds. Assume that a relationship is linear, which of course we know that it's not always, but okay, we'll say it's linear. It says find the slope of the line and discuss its meaning in the context. Now for those of you that are so used to being the best in your class, this is going to be hard because we don't really care what the slope is. I know you're so used to just finding the answers and being great at that. We don't care anymore. We want to know, what is the meaning of this in this context? What does it mean? So let's go ahead and find our slopes. I'm going to take the 70 and the 165 and assume it's a coordinate point like this. Same thing for our 64 inches and 142. So here are the y's, here are the x's. So 165 minus 142 on top over 70 minus 64. So up on the top, I'm going to get a total of 23, and on the bottom, I'm going to get 6. And I go, what does this mean? That's what is really important here. What does it mean? So you might want to just stop for a second and think about it. This is a great point for you to pause. Now I'm going to just tell you, because I'm not going to sit here waiting for a bunch of time. It's a waste of my time. But looking at this was, remember, the pounds. And on the bottom, that was the inches. That means for every 6 inches, you're supposedly going to gain 23 pounds. That's what it means in this context. Part B then says, how many pounds are added for each inch of the height? They want to know, when this is 1, when you have 1 inch, okay, remember that's inches, that's pounds. If this is 1 inch, how many pounds should that person gain weight with? And you could do what we call cross multiplying here. It's just ratios. So what's 23 times 1 divided by 6? Oh, look, just divide 23 by 6 in your calculator. So easy. Here we go. 3.83 repeating. So what does this mean in the context? It means that for every 1 inch, you should gain 3.83 pounds. There we go. That's the basics of our first real big welcome back to school lesson. Here you go.